So I'd like to first welcome back everyone that joined us for the first day of the symposium, and also be the first to welcome you if you are a newcomer to our second day. From all of us at the Lou Lab, we want to thank, and this is very, very important, the U.S. Forestry Department and the Wood Innovations Grant Program for all of their support, not only for us here in South Florida, but across the nation. They've been a really driving group behind getting the wooden agenda moving forward. So additionally, we'd like to thank the organization for all of the work behind the scenes, such as the state of Florida's Forestry Service, the Florida Forestry Association, and groups like WoodWorks, Florida State Implementation Committee. They've been also very helpful for us here locally. So for those of you working in other parts of the country, please keep in mind these people that are in your states and regions to reach out to them for support. They're very helpful in that drive forward. So there's going to be many groups that I'm going to forget, and I feel sorry for that already. I'll just let you know that right now. So please make sure to let us know if we've left you out. We'll try to find ways to bring you into the fold. So day 2 is going to be we want to look at some logistics up front. So we do have some links that'll show up in the symposium chat. So you'll find some links to the panelists and Eventbrite, stuff like that, so that if you're looking for the next event, you can choose that and move forward with it. So you move from event to event. Please also look at the detailed program that's been sent out through Eventbrite. If you have questions, this is critical. We want to really bring questions in from the audience. Please use the Q&A tool. The chat should be and was disabled, so that we keep this as very clean as possible in terms of the presentations. But use the Q&A, and we'll organize those questions and give those off to the panelists. Additionally, we have a Miro board, which has a lot of information that we're actually updating as we go. We're adding links, putting in other stuff that you can go check out that's supplemental to the work that's happening here in the symposium. The Miro board is pretty active in terms of what's going on here in the University of Miami School of Architecture. You can see some work that's currently going on in studios. You can see some work that's happening in the lab, and you can see some stuff that's happening kind of locally within our communities. And if you have questions or additional information you would like to know something about, please email us at latoururbanismlab@miami.edu. That will show up in the chat as well. You can connect to us that way. You can also track some of the work we're doing on our Insta feed, which will also show up in the chat. Okay, so moving on to the meat of why we're here today. So track 2, titled Making, Material, Tectonic, and Building Technologies. So deliberations on making are typically relegated to isolated moments, often underlying a single advancement in material composition, a developing tooling capacity, or through a newly discovered application, for example. Rarely the opportunity to reimagine the entire arc of a process presents itself. For the mass timber and solid wood agenda, the opportunity has arrived, an opportunity that has the potential to significantly alter the way we think through mass timber and solid wood architecture. The extensive discussion involves everything between wood utilization through the construction of the building, challenging antiquated and often compartmentalized practices. Defining a new trajectory for wood in the built environment could engage a performative design directive, acknowledging thermal transfers, embodied energy, carbon generation, sequestration, durability, material consumption, material science, linking building tectonics to territory as an architectural agenda. That's the arc of the symposium. We started with forestry, and we will end in architectural education, if you will. And we're very excited to bring 3 panelists to start off this first moment for track 2. So Jeff Peters is going to be our first presenter. He's the Southeast Regional Director for WoodWorks, Wood Products Council. He's served 5 years in the Air Force, which we want to thank for that service, and holds a civil and structural engineering degree from the University of Florida with a background in structural design and field engineering. For those excited for wood initiatives and call Florida home, we are fortunate to share the Sunshine State with Jeff. He is a tireless advocate for the expansion of mass timber and solid wood structures in South Florida. And the Lou Lab could not be happier with WoodWorks for making him our regional director. There's more to come on our partnership with WoodWorks locally from the Lou Lab's perspective, and we'll be introducing those soon. Our second speaker, Dr. Stokes. Dr. Elizabeth Stokes is an assistant professor of sustainable bioproducts in the College of Forest Resources at Mississippi State University. The work of Dr. Stokes focuses on the application of plant-based compounds, adhesives, termicides, and manufacturing of composite panels, and the treatment and protection of mass timber products. I would say that anybody working in the Southeast should be excited to hear this discussion. She holds degrees from Mississippi State for Women and Mississippi State University. With the emergence of CLT processing, manufacturing, and construction of mass timber buildings in Region 8, Dr. Stokes' research will prove critical to understanding the viability of these building systems across the Southeast. And last but certainly not least, Ulrich Stengel is an associate professor and program director for architecture at the University of Texas at Austin. Uli's work in wood has been focused on the culture and craft of wood construction and its contribution towards sustainable practices. Uli received a diploma in architecture from the Universidad Stuttgart in Germany and a Master of Architecture from the University of Oregon, and had held practice positions at Foster & Partner and Grimshaw. And keeping with the aim of the symposium, Uli strives to foster the dialogue between architecture and engineering, forestry, economics, and material science. With multiple publications on wood building, including sustainable architecture, energy concepts and construction systems, turning point and timber construction, a new economy, and publication out of Timber Symposium conducted at the University of Texas, Time for Timber. Uli is consistent voice in advancement of wood architecture in the US. And again, we cannot be happier to have these three people talking with us today. Again, please use the Q&A as it goes. We'll organize those questions. And no further ado, I will give it over to Jeff Peters.
All right, thank you very much, Chris. I'm gonna go ahead and get my screen rolling here. All right, so like I said, thanks, Chris. I really appreciate you and Shauna inviting me out here today to present. This is a great opportunity. I'm really excited to have some time today to share a little bit about what's been going on in South Florida with the Lou Lab and the partnership that WoodWorks has with the University of Miami School of Architecture. And so today, the purpose of the presentation, my portion is we're really going to talk about kind of the precedence of cross-laminated timber in South Florida and where Miami-Dade really stands, right? They're setting a precedence for a sustainable solution. And so as Chris indicated, I'm the Southeast Regional Director here at WoodWorks, and really our primary goal is to provide technical support and design assistance for the architectural community, for developers, for contractors, as it relates to all things, not only mass timber, but even light frame and heavy timber and hybrid structures as well. So if there's an opportunity to work with you in the future on a project, love for you to reach out to me. And all of our assistance is free. So we're completely supported by industry. And so I just want to give a shout out and a great thanks to the Softwood Lumber Board, the U.S. Department of Agriculture, their Forestry Services Division, and then Forestry Innovation Investments. In addition to our funding partners, we had board level partners and market development partners. So these organizations are really responsible for keeping our organization moving. And so when you're looking at doing a mass timber project or any type of a wood commercial project, I really encourage you to reach out to some of these organizations and look to them, because they're really the reason why WoodWorks exists, and we're here to provide that support. And so one of the cool tools that we put on our website recently is our manufacturer and supplier directory. So you can go to woodworks.org, you can apply filters, search for different products if you want to learn more about who's supplying CLT to the region, or say you're looking for I-joist on a project, you can go through here and find out who those material suppliers are. So let's get into the presentation today. So the first part of what I'm going to be presenting on is really, you may see a little overlap with what you saw yesterday when the manufacturers were talking, but I really want to go through a mass timber overview. Talk a little bit about the products that are available, talk about a couple of case studies, just 2 projects that I just want to highlight, and then what does the code currently say about mass timber, not only in Florida, but across the country? What do we currently have in our codes, and what does the future look like for mass timber? And then we'll really get into the exciting part of mass timber in Miami-Dade County and really kind of go over the grant that Lou Lab received. We'll talk about what opportunity existed for this showcase project to start happening in Miami-Dade, and some of the conditions that were set before us for this opportunity to be accepted. What was kind of the test data that was required? What kind of reports did we have to submit to Miami-Dade County? And then finally, the acceptance. So we're really excited to share this information with you. So jumping in about some of the mass timber products. So I'm going to go over about 6 of them just really quickly. The first one being glulam. Now, this is the oldest engineered wood product that's available in the market, right? It's basically taking dimensional lumber, structural adhesives, you're laminating those and creating a beam out of those. Now, we typically do see those in, say, beam and column applications, but using this product, you can actually lay them in the flat position and use them as floor panels and roof panels. It's not something that we see quite often, but it is being done. So that's the glulam. Next is cross-laminated timber, or CLT, which is really our focus. We're excited to highlight that today. But for those of you who may not be aware of it, basically it's dimensional lumber. They lay that orthogonal to one another, and they use structural adhesives and press those together to make large panels, anywhere from 8 to 10 feet in width, all the way up to 64 feet in length. So if you can picture that, almost like a precast panel, if you will, but all solid wood. And those come in 3, 5, 7, and 9 plies. Now, nail laminated timber is really what it seems to be, right? It's dimensional lumber, face nailed to one another, and you create a panel product that you can lift and place just like CLT, except you're using mechanical fasteners instead of structural adhesives to hold those laminations together. The last 3 products I want to touch on is dowel laminated timber. Now, just as everybody was really starting to get their head wrapped around what cross-laminated timber was, industry introduced dowel laminated timber. And basically what that is the softwood base material. You take 2x material and lay them side by side. And then you take a hardwood dowel that has a moisture content that is less than the base material. That base material is pre-drilled. That hardwood dowel is pressure injected through that base material, and over time, it will wick the moisture out of the base material, expand the hardwood dowel, and mechanically lock everything into place. So the nice thing about this is there's no steel fasteners, no metal fasteners, no resins, no glues, no adhesives. So you have a completely green product from start to finish. Mass plywood panels, or MPP panels, that's really an iteration of cross-laminated timber, where CLT uses dimensional lumber. MPP panels use veneers, like a structural composite lumber, to create large billets up to 24 inches in thickness. So really, we're looking at using these as panel products. They can even be manufactured and fabricated as columns and beams as well. And last, but certainly not least, is heavy timber lumber decking. Now, we see this used quite frequently in applications where maybe a design team feels a little bit comfortable with using a glulam post and beam system, but maybe not really ready to dive into using CLT or something like that. A heavy timber or decking product will actually really give you that look with not necessarily having to commit to learning, CLT and the design of that. Okay. So now, some mass timber projects of precedence here. Let's take a quick look at the University of Amherst, their design building here. This is a really amazing product. It's the most advanced mass timber building in the United States. It's 4 stories, right about 87,000 square feet, and it really exemplifies the university's commitment to sustainability. And if we take a quick look on the inside of this building, you can see it really sets the bar significantly high for mass timber buildings in the US. In this particular building, right, they use glulam column and beam frame. They use actually glulam brace frames, as well as CLT shear walls and a timber composite concrete floor system. So this is really advanced building and really has set the precedence. The next one I want to introduce is T3 Atlanta. Now, T3 stands for Timber, Transit, and Technology. This is the second building that was developed by Hines, and for the second time, StructureCraft was selected by Hines as the mass timber structural engineer on the project and the builder for the timber superstructure. So this is the first T3 was in Minneapolis, and that was completed back in 2016, and it really helped spark that kind of mass timber revolution that we're currently seeing in North America. To give you a little bit more detail about this building, the gravity system is really used dowel laminated timber, like we just spoke of, for the floor and roof panels, and then glulam post and beam substructure. The whole entire lateral system on this building, the perimeter and internal steel brace frames that StructureCraft actually installed in sequence with the timber structure, rather than using like a concrete core. This really helped them speed up the process of construction. So overall, we're looking at a 7-story building, about 205,000 square feet in Atlanta. Really exciting project. Now, mass timber in the code. What do our current codes allow us to do with mass timber. So as it stands today, and yes, even in Florida, we can get up to about a 5-story residential type project with mass timber when we look at, say, type 3, type 4, type 5 construction. That's what we're very comfortable with. That's really the sweet spot for timber construction, whether it's light frame or heavy frame or mass timber. When a business occupancy, we can get upwards of about 6 stories. And so when we think about this, we can really have some great opportunities for residential and business occupancies. And we can really even push the envelope a little bit further by incorporating a mezzanine in there, or putting it on a podium, something like that, to help increase density in areas where we may need that. Now, that's what we can currently do, but what does the future tell us for mass timber? How are the codes evolving to allow us to push that building envelope a little bit further? So in 2021, right, we just reached here that the 2021 IBC actually introduced 3 new types of construction that is specifically created for mass timber. So we'll now have a type 4C that will allow us to go 9 stories and 85 feet. We'll have a type 4B, which will allow us to achieve 12 stories of mass timber up to 180 feet in height, and a type 4A, which will allow us an impressive 18 stories and 270 feet in height. Now, the thing to keep in mind here is each one of these have varying levels of fire protection that is required, and a handful of other requirements during the construction process, which is a conversation that we can dive into at a later time. But really, with a type 4C building, you're going to be able to leave that entire structure exposed. In a 4B building, there's going to be a little bit of an interaction equation that you'll have to apply based on fire area, where you can leave either a portion of the wall exposed, a portion of the ceiling exposed, or doing that and using that interaction equation will allow you to determine the percentage of the structure that you're actually allowed to be leaving exposed in that building. And then in the type 4A building, now that's going to be completely encapsulated. All of your mass timber exterior bearing walls will have to be 3 hours of fire protection. Two of those hours can come from membrane protection, and the additional hour to achieve that 3-hour rating can come from charring calculations. And then the floor panels and roof panels require a 2-hour fire protection. So varying levels of protection required. Will Florida be adopting this? We don't know. The Florida Building Commission has just started their meetings. We just wrapped up, or they just wrapped up the 2021. So they're just starting code hearings and meetings and kind of going through this and trying to determine where we're going to land on this. So more to come over the next several years in the next code cycle. Now, jumping into the opportunity and everything that we're super excited about here, kind of talking about the grant that LULAB received. So in August of 2019, LULAB received a Wood Innovation Grant from the support of WoodWorks. I have been on the team here at WoodWorks. July will be 7 years for me. And previously, there was really no motivation to try to really break into Miami, because we all know it's typically a concrete jungle. And then arrives Chris and Shauna Meyer, who reach out to me and say, hey, we're looking to do this Wood Innovation Grant. Would you write us a letter of support? And so for me, it was a no-brainer to have this wonderful team down there to kind of help be the catalyst, if you will, to get this process going. And so really the intent was to help raise awareness in South Florida of mass timber. And we were able to hold our first event, pre-COVID, just before we hit that, right, in February of 2020. We had the first mass timber event at the Perez Art Museum called Miami Resilience. It was an absolutely wonderful event. We had the opportunity to kind of roll out an introductory presentation on what is mass timber products, and a little bit more in depth in this intro that I did. But really was a way for us to kind of break into the industry in South Florida and start explaining what mass timber is and what are the benefits. That was followed up by an evening event as well at the University of Miami at their School of Architecture, where we had some additional speakers and just really a great opportunity to learn more about what LULAB was doing and the School of Architecture was doing there at the University of Miami. And then in August of 2020, Wood and Everything After, they created an upper level design studio that was taught at the School of Architecture at the University of Miami. And then here we are today with the LULAB at the Wood and Everything After International Wood Symposium hosted by the School of Architecture and LULAB. So really exciting things happening, and I know there's plenty more to come. So what opportunity really existed for mass timber to start kind of working its way into South Florida? What gave us that opportunity? So Atelier May is the design studio that really had this mass timber concept. They have a single family home that was going to be submitted for permitting. And Chris and Shauna had reached out to me, and we started discussing opportunities of how we can get CLT accepted in Miami-Dade County. And so the intent for this was really to be a demonstration project, but really the first mass timber structure to be brought to the attention of Miami-Dade County. Now, we were really fortunate that we had a fantastic building official in Miami-Dade who was really helpful during the process and was really like, show me how we can accept this. And so wonderful communication with the city of Miami. They were very, very helpful during the process, reviewed all the documentation that was submitted to them. And so we couldn't have had a greater team to work with during this process. And so the intent was to use cross-laminated timber for the walls and roof panels as well on this project. And here's just kind of an interior rendering of what it looks like, as well as a site plan of the project. Now, what were the conditions for acceptance that Miami-Dade had in place? And so first and foremost, we had to show them that it was in the Florida Building Code, first of all. So in section 2303.14, that is the section of the Florida Building Code that states that all cross-laminated timber has to be manufactured in accordance with the APA PRG 320 standard. So in order for them to even consider that, they wanted to make sure that the manufacturer met those requirements. The next was section 1626.2, the large missile impact test. I initially thought that was going to be the biggest hurdle for us to overcome, but it really ended up being the wet dry cyclical testing that we had to make sure that we showed that CLT could be superior to their requirements in section 2315. So what kind of data and test reports did we have to submit? So in order really for them to say, okay, we feel comfortable, we see that it's in the Florida Building Code, but what the manufacturer has to prove to us that they meet those requirements and they manufacture CLT in accordance with that standard. And so basically, it fell onto the shoulders of SmartLam, who would be the CLT provider for this particular project, really had to submit their product report showing that they met the requirements of the PRG 320 certification process and that their manufacturing facility was indeed certified. The next step was really, showing how we could meet the equivalence or better for the large missile impact test. And so what this really required is that there had been no traditional missile impact test that had been done on CLT as it would relate to hurricane loading, but a tornado shelter test had been done on CLT by US Forest Products Lab. And so if you look at the difference between these two tests, you can see that there was a significant difference. This tornado shelter testing, really the weight of the projectile that was used was really on a factor of about a 1.5. So the mass for the projectile was significantly higher, as well as the velocity in which this missile would be fired at, upwards of a factor of 2.4 and 3.0 respectively. We're talking 50 feet per second, upwards of 147 feet per second. So Miami-Dade saw this information and said, okay, this test is far superior than what we're requiring. It meets the requirements for the large missile impact test. Then it really came down to this wet dry cyclical testing requirement, or basically the moisture durability test. They really wanted to make sure that once this material was exposed to the hot, humid climates that we see here in Florida, that there wouldn't be any issues with the glue bond or delamination, if you will. They wanted to see that the panel maintained its strength. And so one of the big hurdles that we had to overcome, I should say, was checklist 0475. And that was really for structural composite lumber. So basically plywood and OSB. So prior to this, Miami-Dade had never experienced CLT, and we needed a basket to put CLT in. And it fit the mold for a quote unquote panel product. While it wasn't a structural composite lumber that we were trying to present to them, it was dimensional lumber CLT. The PRG 320 standard still said that you could create CLT out of structural composite lumber. And so the main concern really became that glue bond and to make sure that that panel maintained its integrity and its strength after that cyclical loading test. And so how did we get there? How did we show them? So in order to achieve that acceptance, there's a Canadian standard, CSA 011-2.10, which is basically the evaluation of its structural adhesives for panel products. And so while we don't necessarily require that in the United States, the manufacturers that produce CLT, they don't want to cut off any potential opportunities to have projects in other countries. So all of their products meet this requirement. So luckily, we were able to bring this to the attention of Miami-Dade County. And then you can see here that it goes through a vacuum pressure treatment test. It goes through a boil, dry, freeze treatment test. And really what we wanted to show them was that this test was far superior. So what ended up happening is we ended up leaning on the glue manufacturer that is used specifically for SmartLam's V3 grade dimensional lumber CLT. So Hinkle was able to submit the documentation of the testing to show that their testing criteria supersedes the requirements of Miami-Dade County, and that it was a superior or more stringent test than the requirements that was set forth by checklist 0475. And so really the exciting news to share with you, as of last evening, I received an exciting text message from Shauna stating that they have permit in hand for Miami-Dade County's very first mass timber building. And so while Chris was very kind to point that a lot of this couldn't have been done without my help, I would say that a lot of this could not have been done without the absolutely amazing team of industry experts that we all pulled together to make this happen. There was definitely no one person that made this happen. It was a team effort. And I really just want to give thanks to Atelier May Architects for having the motivation and excitement to do a project like this and be willing to really take that uphill battle. WoodWorks, of course, SmartLam North America, Britt Peters and Associates, APA, the Engineered Wood Association, the American Wood Council, Miami-Dade County, and of course, the University of Miami School of Architecture Lee Lab. Without all of these parties, this definitely could not have been achieved. And so in closing, I just want to thank you for the opportunity once again today to present to all of you. If you have any questions about a commercial wood building, whether it's light frame, hybrid, mass timber, I'd love to be there to help you out. Here's a quick slide that kind of shows you my contact information. And if for some reason you're not able to capture that, feel free to reach out to Chris or Sean, or you can always look me up on the woodworks.org website. And so with that, that concludes my presentation for the morning. And thank you so much for the opportunity.
Well, good morning, everybody. My name is Beth Stokes. I am a professor at Mississippi State University. Apologies, let me get my screen set up going here. Welcome to this fantastic symposium that we're all a part of. I'm so thankful that Chris and Shauna reached out to me to be a part of this, and I hope that I'm able to provide you all with some useful information that we've been gathering here at MSU over the last few years. I'm an assistant professor in the Department of Sustainable Bioproducts. And what I'm going to be talking about today is an issue that Chris and Shauna raised when we first spoke, which is the concern about decay and termite damage in mass timber. I have a background in environmental microbiology and in field testing of wood products for protection and preservation. I do a lot with railroad ties. That is to say, we test a lot of large-scale materials. Our unit's history goes back to the 1960s. We've maintained large-scale field plots, laboratory pilot, industrial scale facilities for many, many years. And we have research facilities in testing of wood materials, furniture frame, chemical applications, wood energy products, and many, many other things. We also conduct real-time trials of wood products and protection systems. So when USDA began sharing an interest in seeing more CLT and mass timber research produced in the US, we were on board. And I say all that to say we're big fans of CLT here. We are mass timber fans around just all over the unit. CLT is one of our focus materials, and we began in 2014 and 2015 to work on several different research lines with it. Our first couple of research lines were looking at termite attack and weathering and decay fungi impacts. We've since moved into strength properties, lumber grade differences, using southern yellow pine to manufacture CLT. We work on industrial mat applications. We look at fastener stress. We look at marketing and mass timber perceptions in society, and so many more things. I have a huge list of projects that we are involved in. And in 2019, we obtained our own retired Washington Ironworks press, and we retrofitted it into one of our facilities to create our own CLT press. So we are now making our own full, 8-foot by 4-foot panels of CLT for large scale testing. That is our first panel that you see there in the picture. It is now on display in our main building. So I say all that to say that our department is really hopeful that by investing resources and research efforts, that we're going to continue to support the development of CLT across the Southeast as a very sustainable, highly desirable product for construction and industrial purposes. We believe this because we know that CLT has an immense potential. We know its potential for industrial matting and heavy equipment use, but we've also seen firsthand the potential for low to mid-rise residential construction. The components for using CLT blend so well in a hybrid system with steel and concrete construction. It has unmatched carbon sequestration potential. It performs so well in seismic and high wind studies. Those have been done over the last 8 to 10 years. And it can be designed to achieve excellent fire resistance while maintaining a really strong structural performance. And we are so committed to seeing this proliferate through the Southeast. Across the U.S., I just threw on some examples of where CLT, we're seeing it pop up. Things from Albina Yard in Portland, Oregon, which was the first U.S. CLT building from domestically produced CLT, to Adobe Hall. This is our new one at University of Arkansas, first large-scale mass timber residence hall and living learning community. Jeff mentioned the Ulver building at UMass Amherst, largest academic CLT building. And from our friends at Clemson, we have the Quattlebaum Outdoor Education Center, which is the first CLT building in the southeastern U.S. made with southern yellow pine constructed panels from the Dothan, Alabama plant. These are not all of them, but these are some of the outstanding projects that I wanted to point out. This also brings up, the map also brings up an interesting area of consideration. If you are not familiar, this is the fungal decay hazard map produced by American Wood Protection Association. The U.S. is divided into 5 zones, low to severe. The Southeast is zones 4 and 5, which are high and severe. So one of the questions that we need to address, we feel that we need to address with mass timber is, what is the likelihood that these structures will encounter deterioration pressures? So far, our buildings have been in zones 1, 2, and 3. We are now constructing buildings in zones 4 and 5 in Arkansas and Clemson and in Florida and in Alabama and so forth. We need to consider the different types of pressure that these buildings would face. If you were to build a simple post and beam structure on your own property, you would ensure that those materials were being used in an appropriate way. We have to consider mass timber in the same way. We cannot just throw it into place and move on. So, there we go. One of the strongest pressures that are facing wooden structures in North America are termites. This is a question I get constantly. My mass timber is going to be attacked by termites. Not if you do the right things. And we know how to take care of termites. Same with decay pressures. Termite pressures differ around the country. If you're in more northern areas, less of a problem, really not a problem. When you get into Southern California, and the southeast, we have heavier termite pressures, not only from our native Reticulotermes species, which you see on the left of the slide, but also from, on the top right, the Coptotermes, the Formosan invasive termite, which is all across the Gulf South, down into Florida, across Louisiana, and unfortunately also drywood termites. There are a few species of drywood termites. Typically, we see issues with these in Southern California, the deep Gulf South, Florida, South Texas. These are the termites that you would find in an attic that don't necessarily need contact with the soil to survive well. And they add a layer of concern in certain areas. So with these pressures comes a need to understand how we protect our wooden structures. We know how to protect structures from termites. We've done this for decades. Your mass timber building should have a strong termite protection plan as soon as you have a site selected. You should be treating the ground. You should be working with a pest control specialist, the same as you would with any other construction property or project. I'll get back to that soon. I will address, while I have time, a few of the research questions that we have investigated so far. They really boil down to 3 areas. Our first question was, is typical CLT adhesive termite resistant? When I first started working with CLT in 2014 and 2015, one of the comments that I heard consistently is termites are not going to go past the glue line. CLT is so massive that that glue line is going to be a barrier. If that is true, it is a brilliant step in preventing termite infestations. So to look at that, we took some CLT sections and put them in the absolute worst case scenario. This is not something that a building should ever see. Absolutely worst case. And I will point out that it is not a barrier. This is a CLT made with a polyurethane 1-component adhesive that has excellent bonding strength, low emissions, reasonable cost, wonderful stuff, very strong CLT, fantastic. It's not a termite barrier. And you see in the yellow circles, our termites, our native termites, were able to chew their way right across the glue line. It's just not a barrier in a worst case scenario. We also determined that it doesn't matter the size you test at. If you test a 1-inch slice, as you see on the left, or if you test a solid cube, as you see on the right, our native subterranean termites, given the opportunity, will go after untreated CLT. The more there are of them, the more damage they can do quickly. Excuse me. We also conducted some field trials. So this is an AWPA standard test called E21. We tested 18-inch sections of 3-ply CLT. These are placed onto concrete blocks that simulate a concrete foundation, but with no barriers between the wood product and the concrete. Additionally, there is a bait stake, a piece of pine driven into the ground inside that concrete block. The idea is to give termites the most access they could possibly have to this material. And do they choose to come after the material or not is the test. So we tested untreated CLT, unprotected, against treated pine lumber, against a treated 4x4 post, and against untreated pine lumber. And when we picked up the CLT, we noticed that the outside doesn't look terrible. It doesn't look particularly destroyed. It looks a little stained and problematic. But we tapped on it with a putty knife, and the putty knife went straight through it. It's basically hollow. So we know that unprotected termites will do damage. and given time, they will do damage. We'll come back to that in just a minute. Our second question has been, how do wood decay fungi interact with CLT? If you'll forgive me, I'm a teacher by trade and training. I need to give a little educational side note. If you don't know, there are basically two types of wood decaying fungi. There are brown rots and there are white rots. White rots tend to favor hardwood species. They remove their lignin components early in decay and leave what you see on the bottom picture, which is this white stringy cellulosic substrate. Brown rots kind of do the opposite. They tend to favor softwood species and they leave behind brown crumbly lignin components as they consume cellulose. These are the two basic types. Fungi also move through wood by producing these thin thread-like cells called mycelia, as you see indicated by the red arrows. They can easily fit through pits in wood cells, and it is very, very difficult to determine early infestation. In the middle picture, you will see some of our CLT sections absolutely covered by a wood decay fungi. And on the right bottom picture, a progression of fungi damage to untreated CLT. Given the conditions, yes, wood decay fungi will attack. However, with the application of CLT, the way it is written in the codes now, it is extraordinarily unlikely that a CLT product used in the recommended way would ever encounter a decay fungi. Decay fungi are not the issue. It is more likely that mold and stain fungi will be problematic. And this goes back to interaction of CLT with water. Water intrusion and dampness provide ideal conditions for surface molds. My postdoc just published a paper in MDPI Coatings Journal on this, where we have coated and uncoated exposed CLT. Outdoors, we have a match set here in Starkville and another set in Madison, Wisconsin. They've been exposed. This is the first 6 months of exposure. In the far right column, you can see the graying of the product over time. The others are coated and have various levels of success. It is mold and stain fungi that are going to make the difference. Why is water such a big deal? Well, that's really our third question. Controlling moisture content is a central tenet of producing wood products. It's all because wood is hygroscopic and seeks to be at an equilibrium. By understanding the effects that water has, we can prevent a lot of the issues associated with wood, including protecting CLT and other mass timber products. To put it simply, water opens everything up. Insects rely on it, decay fungi need it, stains and molds need it. Water damaged wood is susceptible to all kinds of damage. If you don't hear anything else and don't take anything else from my presentation, if you protect your CLT and other mass timber products from water intrusion, your concerns about damage are going to be minimized. Nothing, other things rely on water. If you protect it from water, you've done 95% of the hard work. So we boiled this down into really 4 ideas. How do we apply CLT in a responsible manner? Consider the location. Have you considered where you're building? Are there heavy storms predicted? Are heavy storms typical? Is this a high termite pressure zone? Have you considered the material? Is this going to be a southern pine or Douglas fir? What is the adhesive? Can you add a water barrier? Are you going to use treated or untreated material? Should you use a water repellent coating in a particular area? Consider your structure. Your HVAC system, you should be preventing leaks and condensation anyway. It is especially important when you are using HVAC with CLT. In your openings, there should be no exposed, unprotected CLT material in a window frame or door frame or any other opening. Consider where your plumbing is being run. Is it going to be inside any ductwork outside or between panels of CLT? Is there a chance for leaks and condensation? What are your roof overhangs like? Is there enough depth to keep blown rain off of it? How high is your trim and siding from the ground? Considering your occupants, what's the building's use? Is there an area that's going to require heavy water demand? Most importantly, we have found, can your facilities personnel be trained to recognize the signs of water damage and handle it appropriately? We have found that this is going to be, we think that this is going to be a key area for maintaining these structures for a long time. There are a few of these CLT structures. I know the Promega building in Madison, in Wisconsin, has built-in moisture sensors throughout their CLT. They're monitoring the moisture in their building through its lifetime. What I would like to end with is a request for you. I would like to ask for your advice and help. We use the ICC manual and the CLT handbook all the time as references. They're fantastic. They don't include a lot of the environmental information that we would like to share. What would be the most useful way that research groups like ours, like Clemson, like the Forest Products Lab, would be the most useful way to disseminate this information throughout the industry? Would it be a benefit to have a chapter added to some of these reference materials? Should we generate something new? We would like your input on this because there is going to be a vast amount of information that can be shared. And with that, I will stop and say thank you very much from a recently snowy Starkville, Mississippi. Not today, it is very rainy. And if you'd like any references or like to contact me, there's my contact information.
Thank you to Jeff and Elizabeth for these really informative presentations. And I think my presentation will conclude this session. And oops, sorry about that. Hang on for 1 second. And I think it will tie in nicely with some of the things that Elizabeth was talking about. I want to quickly thank Shauna and Chris for inviting me to be part of this event. It's an honor to be in company of so many esteemed experts and colleagues. So in my presentation today, I'm going to talk about an aspect of wood that is not discussed in depth in the profession very often or taught in school. And I wish it's something that I had learned about sooner in my career. And as Chris mentioned briefly in the beginning, I've been researching wood construction for a while now, and my work culminated in 3 book publications that you see here. And I'm pleased to report that I've gotten feedback from many of my colleagues, especially the second book, Turning Point in Timber Construction, has been a useful resource in the classroom at many different schools. So I'm going to talk about exposed wood, weathering and protection. I'm going to mention railroad ties for just once or twice. So hopefully with Elizabeth being an expert, I'm not making any wrong statements here. But here's a quick overview of what I want to cover today. So I'm going to talk briefly about the history of wood preservation. I'm going to touch upon natural and chemical preservatives, coatings, and modified wood that all kind of address the durability of wood. And then I'm going to conclude with detailing and assembly and untreated wood facades. And those 2 last items are really kind of where my main interest and research focus lies. So attempts to preserve wood are virtually as old as the use of wood itself. And there are early examples that date back to Greek and Roman times. There are reports that in ancient Greece that bridge wood was soaked in olive oil before it was used for construction. And then the Romans obviously had an extensive naval fleet that was built out of wood, and they brushed the hulls of their ships with tar in order to protect them from rot and decay. There are some historical European documents that in which the term ox blood can be found, which describes a type of paint that was used to protect wood. And contrary to popular belief, however, the paint did not contain blood, which obviously would have had, first of all, a very short workability time span. Blood would have not provided very good coverage. It would have faded, browned, and possibly even molded. But rather, the term was used to describe a red or reddish brown color, which had the appearance of cow ox blood. And the red coloration likely came from additives such as iron oxide or red ochre in the paint. Now, for centuries, preventative measures were really the primary means employed to extend the lifespan of wood and its serviceability. And that obviously included selecting durable species, determining the right time for harvest or drying, and then most importantly, appropriate architectural detailing. And those methods were utilized by craftspeople over hundreds of years. That expertise accumulated and it was passed down from generation to generation. And following these rules allowed the construction of timber structures that were able to stand the test of time, and they provided sufficient evidence that the notion of wood as a short-lived building material is misconceived. So there are Austrian farmhouses that still stand from the 17th century. The oldest Norwegian stave churches date back to the 12th century, and there's some Japanese monuments that date from as far back as 800 CE, making them one of the oldest surviving wooden buildings in the world. Now, in the United States, the commercial production of wood preservatives began in the 19th century when vast amounts of wood were being used to close the frontier through, on one hand, the construction of the railroad, and then also to electrify the country. Wood was widely available and a lot less expensive than other materials when it came to producing railroad ties and utility poles, for instance. But then again, these were in contact with the ground and had to be protected, and which led to the introduction of pressure treatment for wood. And in many cases, that was accomplished with creosote. And you can see one of the historic creosote treatment facilities here on Bainbridge Island in Washington here on the right-hand side. So let's quickly look at what happens with wood that is exposed to the elements. So there are photochemical, biological, and physical processes that alter the chemical composition of wood surfaces, and in worst cases, they can lead to decay. The lignin in wood is an organic polymer that's responsible for binding the cellulose fibers together, and due to prolonged exposure to ultraviolet light, that lignin degrades over time. And this decomposed lignin is soluble in water and can be dissolved and washed out by driving rain. And this leaves behind white cellulose fibers. Moisture and from dew and precipitation then encourages the growth of microorganisms such as stain and mold fungi on the fibers, which leads to the familiar grain of wood. Now, depending on the environmental factors involved, this color change does not occur evenly, especially if you have protruding building elements that partially protect wood surfaces, as you can see here, what's happening here with the windowsill on the right picture. And so there might be an uneven aging process across exposed wood surfaces. But all untreated wood surfaces, regardless of species, undergo the same transformative process. So this applies to low-grade softwoods that might come from temperate forests and also applies to high-quality tropical hardwoods. As long as the wood can dry out and there's no decay present, these physical changes do not really affect the strength or the integrity of the products themselves. So Elizabeth already touched upon, how do we control decay? And I'm just going to repeat it here. The most effective and practical method of preventing decay is controlling the moisture content of wood. Optimum conditions for decay occur, above 20% moisture content, around 25%. And if wood is installed and maintained below a moisture content of 20%, it will not decay. And that situation is true for most wood in protected conditions. If moisture content will exceed 20% due to exposure conditions, then there are options to treat the wood with a preservative, or you could choose a naturally durable species. Now, in terms of naturally rot-resistant woods, there are species that are resistant to decay in their natural state, and that's due to high levels of organic chemicals called extractives. And these extractives are deposited in the hardwood of certain tree species as they convert sapwood into hardwood. Now, we're all familiar with the range of tropical hardwoods, ipe, teak, myrrh, bauma, saranduba, and others that possess some of those qualities. But a lot of us might be hesitant to employ some of these products due to some of the sourcing issues that come along with it. There are some domestic rot-resistant species, western red cedar, eastern red cedar, black locust, black walnut, redwood. Some of these species tend to be prohibitively expensive for general construction applications, obviously, and some of them might not need the required properties in terms of hardness or in terms of structural properties. And some of them, such as the redwood, are even on the IUCN Red List as an endangered species. So we have to be also careful here which species we employ. Then we can resort to chemical preservatives. And this list is obviously by no means exhaustive, and it also contains some of kind of early wood preservatives that are actually no longer used in building construction applications. But we can generally classify waterborne preservatives and oil-borne and creosote-based preservatives. The waterborne preservatives are most commonly used for pressure treatment. They tend to leave the wood clean, odorless, and easy to paint, stain, and finish. They tend to be less environmentally hazardous than other preservatives. The oil-borne and creosote-based preservatives, on the other end, now they're much less used than waterborne equivalents. They tend to be used for non-building construction applications such as utility poles and railroad tiles, and they're actually being less and less used each year and may eventually be banned altogether due to the environmental concerns. There are different application methods for chemical preservatives, non-pressure methods that involve brushing, spraying, dipping, steeping, soaking, but then we're mostly familiar likely with pressure processes that provide a deeper and more uniform penetration and higher absorption rates of preservatives, and also allow large-scale production. The American Wood Protection Association is a nonprofit organization that disseminates voluntary wood preservation standards, and most specifiers of treated wood recognize and use these standards. And they're developed in an open consensus-based process that involves individuals from all facets of the wood preservation industry. And it's really about making sure that treated wood performs satisfactorily for their intended use. And if you pick up a piece of treated wood, you might find the end tag stapled to the end grain, which will, if it follows AWPA standards, will give you information about the standard employed, the preservative, and other additional information. Another way to protect wood are coatings. We've talked about UV protection that leads to UV exposure that leads to the decomposition of lignin on untreated wood surfaces. And the pigments in stains, lacquers, and paints protect wood from UV exposure. They also provide a certain level of waterproofing, reduce the absorption of moisture. They provide mechanical protection from dirt, driving rain, and hail. Most and foremost, they impart color and actually can ensure color retention. And it really depends on kind of the opacity levels of those coatings. So paints and opaque lacquers provide the best protection because they block all UV rays, whereas semi-transparent stains will offer some, in most cases, sufficient UV protection. The most effective ones contain iron oxide pigments. It's very much like a mineral sunscreen that you might apply to your skin that contains zinc or titanium oxide, which is literally about reflecting that UV radiation. And then lastly, transparent coatings are not really very suited for exterior applications. They might provide some water repellent qualities, but they really don't block any UV rays. There are other ways to protect exposed wood through modification. You might have heard of thermally modified wood, which involves heating wood to high temperatures in the absence of oxygen. That prevents the wood from burning. And then through this treatment process, the wood becomes much less hydrophilic, which means it tends to absorb less water and becomes more dimensionally stable and less susceptible to decay, rot, or insect attack. Any wood can be thermally modified, which means that, and it turns the wood kind of a dark brown color, which means that some otherwise nondescript woods can be turned into kind of quite attractive products. The downside is that the strength and stiffness values can be reduced compared to the original wood, in some instances that's up as much as up to 30%. And a lot of you might be familiar with shosugi ban, which is a Japanese tradition of burning wood siding that dates back hundreds of years, where the Japanese discovered that a heavily charred board used for siding was much more resistant to rot and insect infestation, and also a lot less likely to ignite when exposed to sparks or flames. And this method was vital in reducing fires, but is now primarily used for aesthetic purposes in exterior applications. Neither of these products are really suitable for structural applications. There are some other modification methods. One of them is acetylated wood, which involves the chemical modification of wood at the molecular level to improve its performance properties. There's currently only one manufacturer that I'm aware of, named and goes under the Koya brand. They use Monterey pine. And according to the manufacturer, this makes the wood more dimensionally stable and highly rot resistant, and also apparently is non-toxic and does not have the environmental issues associated with traditional preservation techniques. They claim that it is durable for 50 years above ground and 25 years in ground and fresh water. And then lastly, furfurized wood is a wood that's impregnated with furfuryl alcohol produced from a bio-based liquid to make it dimensionally stable, which then undergoes a curing and dyeing process. And currently only aware of one manufacturer as well, Cabony, and they also use Monterey pine. And also the manufacturer also promotes it as a product that contains no toxin or chemicals, but it's mostly currently used in decking and cladding applications. The acetylated wood Akoya brand I've seen used in structural applications. As you can see this small picture here with the bridge that's completely exposed in the Netherlands. One of the most effective ways, and kind of going back to it though, in protecting wood in exterior applications are preventative measures that are related to proper detailing and design. And there's a German language term that describes the process well. Of course, there's a German language term for it. It's called konstruktiver Holzschutz, which is hard to translate into English. A poor translation of it would probably be constructive wood protection. And I believe we should exhaust these strategies before resorting to chemical treatments and coatings. I tell my students when they go out in the rain, they carry an umbrella, wear a hat, and they wear rubber boots. So maybe your building, if it's made out of wood, should do the same. It's also about nurturing and understanding that, standing water on horizontal surfaces should be protected, should be avoided. So protecting those horizontal surfaces. So those initial conceptual design images might actually look quite different once a proper wood protection strategy is implemented and something is constructed. And also understanding that the end grain will continue to absorb and wick water, just like the trivial living tree did, and covering up that end grain and protecting it. And again, keeping it out of water and allowing, it's really about allowing things to dry out. And so even if the wood gets wet temporarily, allow things to dry out. And untreated wood is, very popular right now in facade applications. And I always cringe at the examples that I walk past where vertical, tongue and groove cladding is just butt joined at the horizontal joints. There's no opportunity for those at the end grain to dry out. That's where the boards are going to rot out first. And it's really about creating buildings that, that have longevity, and we're not changing things out after a few years' time. Just kind of quickly, what an untreated wood facade looks like when it's done properly. It's got an overhang, it's got a roof, it's got wherever the board ends, there's kind of a flashing that protects the end grain. There will be uneven weathering that might actually never even out depending on what the environmental conditions are. There's also, in this picture, it's hard to see, at the foot of the foundation, there's a gravel bed around the building, which really reduces the splashing effect of the water against the wood siding. And it's really about detailing buildings for longevity and also setting up client expectations. So this is, the picture on the left is kind of the money shot when the project is completed and published, but it starts looking differently a few years down the line. And just making sure that your client is aware of that. And it's also about cultural acceptance, because what is accepted in one part of the world might not be accepted in another part. So in closing, I just want to say that our relationship to wood is somewhat ambiguous. We love the natural, unique qualities of wood, but we use all means to halt or slow down its inherent natural aging processes. We love its ephemeral character, but we do everything possible to ensure its perpetuity. And I'm aware that not every wood building will feature exposed wood, but if it does, we need to make sure that we're protected properly and don't design buildings that don't last, because ultimately this will not help us in making the case for an increase of wood in the use of construction. Well, that concludes my talk. And thank you all.
Yes, thank you guys for informing us on the ins and outs of the current state of CLT or wood in general. I want to say that this was one of those talks, this panel was one of those talks that kind of circled as we were putting this symposium together, because some ways it's the meat of everything coming together. Can we make this wood agenda happen? What is it going to take? How are we going to rearrange our preconceived notions about the processes of wood? Can we be better at adjusting our expectations? And I think everybody today has kind of talked through what it really takes from both policy, as Jeff was describing, Dr. Stokes looking at just how real are we at understanding the pressures and the severities of the concerns in our regions. And then Uli talking just through what is wood going to do when it is exposed to weather. So very exciting from my perspective to see this panel happen. I want to go, because the audience has provided some questions, I want to go to some of those questions and see if we can address some of their needs. So I think one of the questions that came in that was interesting is in regards to infrastructure. So one of our attendees posited, could we replace parts of our concrete jungle or civil infrastructure with CLT panels and or other mass timber products, with the understanding that we would have to replace modules incremental over time? So time comes into play. I think everybody in some ways are talking about this aspect. So the attendee goes on to say, to think sacrificially for surfaces similar to the CNC milling bed, but in the case maybe a road surface or highway or a partition wall. Hopefully this would produce a regional economic cycle, expanding regional and national jobs and propelling more consistent growth to harvest ratios in regional timber farms, life cycles, etc. So in short, can we convert the civil plans and use concrete for more long-term ephemeral infrastructures and using non-renewables? Or could we use mass timber products for short-term ephemeral infrastructures using renewables? I think actually, Uli, you have been working on this in terms of economics as well. So maybe you can address that right away.
Yeah, I mean, really, if you design a, I mean, I'm kind of going back to buildings. If you design a wood building that's all wood inside out, there are, I mean, if you quote Steve Brand's sharing layers of change, there are certain things that are permanent and fixed, and there are certain things that you're going to have to replace and more frequently. I mean, I think the topic that I've talked about, exposed wood, is, I think it's also, it might work in certain, like on a building, it might certainly work in certain locations. It might not be suitable in an urban environment and in an urban context. And I don't think it has to be. But I think wherever it makes sense, I think if we're using something that's a sacrificial layer, I think we should make sure that, again, we employ, rather than having to resort to chemical preservatives and anything that might affect the environment, maybe we're using things that are untreated, that can easily, turned into something else or used for energy generation later on, once their lifespan has ended. So I think there's definitely an option. At the same time, I'm not a person that says, we should use wood at all costs. I think we have to use it where it makes sense, right? I mean, we're not going to make wood pilings we do that, but let's use concrete for foundations where it makes sense. And I mean, if a wood siding or cladding doesn't make sense in an urban environment because of its context and its durability, then let's not use it. But there's still plenty of embodied, carbon and embodied energy in the wood that's going to be part of the structural system of a building. So I think there is an opportunity to use these sacrificial layers. I'm not quite sure I would apply to road beds and things like that. They're, experience high wear and tear, but maybe Elizabeth can speak to that since she already works with construction mats and research of that kind of sort.
Yeah, I would agree. Roadbeds, probably not. Noise barriers, on the other hand, I can tell you that there is active research going on right now at a collaborating university in regards to, can CLT be made into an effective noise barrier, and can a system of installing them so that they have a longer lifespan. They're investigating an appropriate system for installation and how to protect them appropriately and have a visually appealing and effective noise barrier for highway systems. So that research is going on. So I would answer the question posed as yes, maybe. It's being examined.
That's actually fascinating that you bring up the kind of infrastructure that's going in place now relative to maybe less structurally dependent for, say, for instance, a building or maybe a bridge or something like that. And it's, for us in the South, I think that what we are grappling with relative to one of the first panels that came to, which was the forestry panel, we have to find ways to do something with the wood that's maybe knocked down from hurricane or storms, or what we do with that wood is important, instead of just letting it kind of rot on the forest floor. So potentially some of these infrastructural things that are maybe less dependent on, collapse, if you will, could have some viable opportunities for the future. Jeff, I don't know if you want to respond to that question as well.
No, I think both Uli and Elizabeth handled that very well. And I was just going to echo what Beth was saying, is that I'm aware of research that's actively happening right now as well in using cross-laminated timber for noise barriers. And I just want to, I would say that when we're looking at using mass timber products, especially here in Florida, I think we need to be very hypersensitive of the use and application. As we're really following this momentum, if you will, of mass timber in South Florida, we want to make sure that we're using them in the right applications, because what we don't want to do is specify CLT in an application where it's not intended, and then the public perception is going to be that, oh, this is a terrible product, it's not sustainable, it's not durable, I should say, not sustainable, it's not durable for this environment that we see here in South Florida, when in actuality it is absolutely durable enough, but we have to make sure that we are specifying it in an appropriate way. So I think that as long as we maintain that focus here in South Florida and understanding the type of structures that we're designing and implementing here in the Southeast are significantly different from what we're seeing in New Mexico and Arizona and Nevada, where, they get 4 days of moisture a year, right? So significantly different. And I think it's critical to keep that in mind as a designer, as we look and seeing where this material will function well on our projects.
I'm going to go with, there's one question here that, and we have time maybe for everybody to address it from the audience. It has to do with education. Now, this question was actually focused towards the help in student work, and I'm assuming in this instance for architecture students. However, I think because of the kind of cross-section of our panel, I think the idea that we're educating people that are new to this or that are coming into the kind of arena of wood, maybe this makes sense to have each one of you guys respond to it in your own particular teaching moments, if you will. So it says here, do you have any maybe lower level, more entry level support dedicated to reviewing, in this instance, student work, but it could also very much be a professional that's just starting out to help shepherd future timber architects of tomorrow? And I think that from each one of you is coming from a school of architecture, a material science area, and then one of them from the profession. I think each one of you have the opportunity here to address the importance of education for people that are just looking for a fundamental baseline knowledge so that they don't, as Alan Organsky said last night, we don't screw this up.
Who wants to run with that first? Should I start? All right. So at WoodWorks, our real focus here is really to work with design professionals that are practicing in the industry on these commercial projects. But that's not to say that there's not opportunities available for architectural students or engineering students to help foster them, because I understand and WoodWorks understands that these designers that are going through school right now, they're our future, right? And so we want to empower them with the right tools that they need so that when they graduate, they can go out and eventually they're going to be decision makers. And they're going to remember the people that helped them along this journey to where they are in their career. And so one of the things, if I could just share my screen really quickly, I had something kind of queued up that I wanted to share with everybody, in that really the state of mass timber. Let me see if I can get this here. Right, we have WoodWorks is aware of over 1,000 projects, 1,060 projects as of December of this last year of mass timber. We're under this impression that this is only happening out in the Pacific Northwest. But this is the first year on the East Coast where we've really seen this increase in mass timber. And these are, the projects that we're aware of. And so in terms of how we can help you learn a little bit more about it at that educational level. I really would encourage you to check out the WoodWorks Innovation Network, or we call it WIN. And so this is an opportunity not only for students, but design professionals as well to go on this website, and you can actually, all these little pins are projects, and you can go on there and you can look on the particular project. You can see what materials were used on that project, the design team that was on there, and you have an opportunity to communicate and connect with them. So really just a fantastic tool that we have compiled. Now, right now, this is mass timber. We'll add some light frame stuff over the end of the year. But right now, this is an extremely powerful tool. So you go to the WoodWorks website, under the About tab, you can see WoodWorks Innovation Network, and then you can click on that. And so really, in addition, we have a tremendous amount of archived webinars and just presentations that we really have available at no charge for anybody. If you're interested in, please send me an email and I can guide you. And I'm always happy to spend a little bit of time with you talking. I think Chris and Shauna both know that I'm very accommodating in terms of just helping people understand where this wood movement is going. And if you have specific questions about design, I'm here to help you with that. I'm always happy to help out whenever I can.
Yeah, I mean, one of the first organizations that I got involved with here in the United States was actually WoodWorks, and it started with the Wood Solution Fairs, and I believe, Jeff, those are actually free for students, I believe, or a very nominal charge, right?
Yeah, we started them free, and then over the last couple of years, we did put a little price, but they're very inexpensive and typically free for students.
I have the reminders, the monthly reminders of the webinars. I attend all of those. That information is so invaluable in learning about these case studies and hearing all these professionals, from all across the country talk about these things. I mean, that information is available to students. And when I first started out teaching, I'm obviously in Texas. I'm not in East Texas where they're the piney woods. I'm in the middle of the Texas where there's not significant tree growth. There's not, expertise in wood. So when I started teaching that topic, I had to find resources. And I actually started using Zoom before anyone knew what it was. And, I had people call in from Europe and from the Pacific Northwest because I didn't have the resources to fly experts in. But I found that everyone, the engineers, the foresters, the architects, they're also willing and happy and eager to talk to our students. And this format now has made it even easier, right? All of a sudden, everything is international. Everyone's within reach. It's so much easier to ask someone to speak for an hour versus having them get on the plane and spend 2 days out of their schedule to give a talk. So I've used that resource, and I think I would encourage the ones of you that are teaching in areas that might not have that expertise, just go outside of that and reach out to the experts that are, again, they're just a Zoom call away now. So.
And I'll just add a 2-second thing to that. We are from another side of it, because these guys are WoodWorks is very involved in professional education. We are an educational, program, a degree granting program here. And my department head has for a number of years worked with our engineering program and our architecture students. And I think we have a course with each of them where they come over and design a beam with us, a glue lam type beam. And it's a competition, and they come over and we have a giant 600 kilonewton beam breaker set up, and they come over and design their beam and build it. And then we break it for them. And so they get to see, some active involvement. We are trying in our educational curriculum to broaden our reach into the architecture and engineering divisions, because we feel that their students would benefit from hearing about this and offering some of our classes as elective or general education classes to them. So that's something that we are actively pursuing. And I think some other universities are doing very similar things.
Dr. Stokes, there's always a seat at the table at University of Miami for you. So keep that in the forefront. Uli as well, your seat is always reserved here. Thank you guys so much for your time. We have to wrap this symposium up. For those of you that posed questions in the Q&A, we haven't forgotten about you. We'll grab those questions out of the Q&A. We'll try to get some responses from our panelists on those, and we'll post them in the Miro space. Yes, I know it seems self-serving to get you to go to the Miro space to get your answers, but it is a way for us to post those there. We'll also try to reach out and get some of the resources that were put out here today and see if we can get those linked in the Miro space so you can go there and obtain them all in one spot. I want to say that our next chunk of symposium will happen beginning at 11:15, and it will be handling tectonics. So we look for you to jump onto that session, and you can also be bringing questions over that maybe didn't get answered here for those individuals. Again, I want to extend my gratitude towards all of the people that are joining us via remote. I want to extend a very big thanks to our three panelists here today that shared their time and knowledge. This is an enormous part of getting the mass timber agenda off the ground, particularly in the Southeast and Region 8. So thank you for all of your work. We'll be connecting with you in the future, and I'm sure there'll be upcoming events where all three of you will be talking again with us. So we'll look for the next symposium tracked, and thank you again for joining us.